Hey guys, welcome to the last set of notes for Chapter 6. This is Lesson 6-7, Equivalent Expressions. Today's date's 2/13/2020. To be honest with you, I think this is a lousy title. Basically, what we're going to do is talk about the third thing that the distributive property can do, and that's called combining like terms. But in order for us to discuss that, we need to get some vocab straight. You're going to get tested on this. I'm going to ask you, name all of these, name all of these, name all of these. We'll practice it in class, but you got to understand the language or you can't do the math. So let's start off with our friend we've been dealing with, Mr. Distributive Property. So the distributive property this guy uses multiplication. I'm yelling at you. Super important. Uses multiplication to remove parentheses. That's his job. Okay, that's his job. Then we learned about factoring in the second set of notes on lesson 6-6. And some people refer to it as being the opposite of the distributive property. So if the distributive property's job is to use multiplication to remove parentheses, we're going to go the opposite direction, and we're going to do the opposite of multiplication, and we're going to use division. So uses division, and silly enough, guess what? We're going to put those parentheses right back in. Crazy to put parentheses back into an expression. So we do and undo is basically what's happening. So let me give you an example. We've got 27x plus 36, okay? And we talked about yesterday, or 2 days ago, using that factor ladder and doing the factoring that way. I'm just going to kind of cut to the chase on this one and think about it this way. What's the GCF of 27 and 36? And it's like, wait a second, that's easy. The GCF is 9. So if that's the case, I'm going to divide each of these by 9, and that's going to give me 9, and then whatever I have left over. So 27 divided by 9 is 3, so I get 3x. 36 divided by 9 is 4. And that's the answer to this. We've got to find the GCF. Okay. Now, notice that there were two values in my example. Those have names. Term. A term is a, there we go, number, a variable, or a product of numbers and variables. Now, what's funny is I just did a set of notes tonight for algebra, since I'm not there in class, and terms are also called monomials, so we get a little fancier as we get into the algebra class. So how do I know what a term is? Okay, well, it's pretty easy. So in expressions, terms are separated by addition symbol, or subtraction symbols. A lot of yelling going on in these notes tonight. Sorry about that. Crappy. So the adding and subtracting separates terms, okay? So I'm going to just give you a couple of examples of what terms are. And we've got things like a number by itself, 5, a variable by itself, x. We have a product, 17y. These are all examples of terms. All are terms. Okay, now let's look at the 5. He's got a name. He's called a constant. So that makes sense that a number is called a constant because 5 is always 5. 35 is always 35. 276 is always 276. So the number never changes. It's constant. So it's a term with no variable and it's number only. Okay, so some terms have a different name. For example, the term of just a number is called a constant. Okay, so when I'm asking you to read something to me and you see that 5, you're going to say the best word for 5 is a constant. So we always want to use the best language possible. Now, I'm going to go on to a second screen. This is still the first page. I know some of you are big writers. You may be moving on to your second page. Remember, we are going to be doing examples. We have one that's in our foldable that we already glued in. And then if it takes you 3 pages, that's fine. Don't worry about it. Okay? But probably the most important word is this next one. Coefficient. Long word for such a small thing. So the coefficient in the product of a number and a variable in the product of a number and a variable, the number is called a coefficient. Okay, so let's give a couple of examples of those. If I have 6a squared, 6 is the coefficient. If I have negative 5ab, negative 5 is the coefficient of that term. If I have 3x, x is the coefficient. So in these cases, 6, negative 5, and 3 are all coefficients. Now the next thing we need to talk about is crucial to understanding this idea of combining like terms. And that is like terms. What the heck do I mean by that? So like terms are 2 or more terms that have the same variable with the same exponent. Okay, so an example of like terms would be like 3x and 7x, or 15y and 8y. Inside our foldable, we'll talk about things that are not like terms, okay? Now, the point behind this whole set of notes today is to talk about how to combine them. So, to combine like terms, and just think the word combine means to put together. So to combine like terms, we are going to add or subtract. It depends on what the sign tells us to do. We're mainly going to see adding in our problems. The coefficients of the like terms. Okay. Now, when I do this math, okay, when I do this math, it's very important that you understand that variables never change. And I'm going to yell a lot. Variables never change. So it's the only math that's happening is to the coefficients, okay? All right, so we're going to go to the next page of our notes, and that's where the foldable is going to come in. Okay, so here we are on the second page. At the top, we glued in the combining like terms. I need to do my adjustments on this one. So where we see subtraction signs, we write plus signs, and then we're crossing off this guy here. And then on the inside, all pluses where it says minus. So there was 4 of them over here. Okay, so let's look at the outside. It says in an algebraic expression, a term is a number, a variable, or the product of a number and one or more variables. So they gave me an example of 6a squared in plus 5ab plus 3b plus 12. And it's told me about 12 being a constant, and it told me about coefficients. So I'm going to go ahead and highlight the coefficients. So that 6, that 5, that 3, those are coefficients, right? That's the numerical factor, so number that's getting multiplied in a term. And then we have our constant, which is the guy right here, 12, and he's a term that has no variable. And then like terms have exactly the same variable factors. So we specified in the notes, same variable, same exponent, okay? So let's talk about on the inside how we're going to fill this in. So I'm going to give you some examples of like terms and unlike terms, and we're going to kind of trade off between them. So like terms would be like 28z and 13z. So since they both have the same variable, they're like terms. So what could make those unlike terms? Well, we could have 28z, but its partner would be 13y. The variables are not the same, so I can't combine them. All right, let's go back to another example. How about 3a and 9a? That's pretty simple. So how could those become unlike terms? Well, what if I had 3a squared and 9a? So yes, they both have an a, but one has an exponent of 2 and the other one has just exponent of 1. They're not like terms. Okay? Ooh, 7a squared b plus, or let's say and. I don't know why I wrote plus. Let's try that again. And 12a squared b. So they both have an a squared and a b. So how can we make them not like terms? Well, we could say 7a squared and 12a squared b. So the big difference is the first guy doesn't have a b, whereas the second guy does. Okay? All right, so what I want to talk about is how this can get related to the distributive property. So remember what we were talking about? That we were looking for like terms or common factors when we were doing our factoring on Tuesday. Well, what I want you to notice that's common here is the variables. So what we could do is we could factor out the variable. What does that look like? Well, we're going to have x squared over here. So basically what I can do is divide x squared out of each of these. Now I can do it the way that we did it before with the factor ladder. I'm just showing you a different method this way. I'm sorry, that's not what I want to do. I don't want to divide by 3x squared. I just want to divide by x squared. Okay, and what's left behind is a 3 plus a 5. Okay. And so I can factor out a variable. That works out kind of nicely. And what do I end up with? Well, I end up with a coefficient of 8, and we have the like variable of x squared. Okay, let's try another one. What do we see that they have that's the same? In the second one, well, they have a c in common. See there? So what I'm going to do is factor out the c. So what is that going to give me? Well, 5c divided by c is going to give me 5. And c divided by c, well, anything divided by itself equals 1. So I have 5 minus 1. And then I do the math I can do, and 5 take away 1 is 4. And I end up with 4c. Okay. And the last one, let's just look at the variables, and we have 9w minus 3w, and what I notice is they both have a w in common. So I'm going to factor out the w. And that leaves me inside 9 take away 3, which equals 6w. Okay, so over on the other side, it basically tells you what to do. So we're going to give you a compound problem, so that means we've got more than one thing happening. And it says separate all the terms and watch your sign. So basically what they're trying to do is to make sure that all the terms are separated with pluses. Now in our case, that's probably how it's going to show up anyway. And then it says to group like terms, and then to simplify each group of terms. So we're going to go ahead and do that. So first thing we're going to do is we're going to circle up anything that has an A. Okay, I'm going to make this darker. It's kind of light over on that end, so I'm going to try that again. Okay, so that gives me a 5A and plus a 3A plus an A plus an A. All right, let's look for variables. So one thing that you need to kind of remind yourselves, or maybe just understand, is that if we have more than one variable, we're going to put them in alphabetical order. So variables in alphabetical order. And then our constant, though, is going to go in a special place at the end. So constant at the end. That's kind of standard protocol when you're writing these expressions. So let's go ahead and add to that. Let's find the next group of variables. Let's see, let's do, I see 4b and I see a 6b. So that's going to go in parentheses. We've got 4b and 6b. And then we're going to look for constants. Excuse me. So we're going to add. I see a 2, a 12, and a 1. So 2 plus 12 plus 1. And then I just start doing math. Now, one thing that you may not understand, because this is kind of new, that when I don't see a coefficient in front of a variable, it's there, it's just 1. So basically what I'm going to do for the first group is I'm going to factor out the variable, which is a. And that's going to leave me behind with a 5 plus a 3 plus a 1 plus a 1. So this is kind of what the brain step is. What is my brain actually doing? Here, second grouping, I'm going to factor out the variable b, and that's going to leave me a 4 plus a 6. Now, for the last group, there's nothing that I can factor out because there's no variable, so it just stays kind of the same, right? So 2 plus 12 plus 1. So then we do the math, and we end up with 5 plus 3 is 8, plus 1 is 9, plus 1 is 10, so we have 10a. And then with the b's, we have 4 plus 6 is 10 and the b. And then we add up the constants, and we get 2 plus 12 is 14, plus 1 is 15. So my answer, when I simplify, combining the like terms, was 10a plus 10b plus 15. Now, I'm going to go to the next screen to do the last two examples, still on the same second page. Directions are going to say simplify. So first one in this grouping, we have 14y plus x plus 22y. Excuse me. So this is where properties we studied show up. So for example, I want to change the order of things so that the x comes first. So that's going to be commutative property. I'm going to use commutative property, and I'm going to rearrange so that it says x plus 14y plus 22. Now, in doing that, I also put my y's next to each other. So if I want to combine like terms, I'm actually going to be using the associative property, right? And I'm going to put parentheses around the terms that I can combine. So the parentheses are going to go around the 14y and the 22y. Then I'm going to do the distributive property. And the distributive property says, I'm going to go ahead and factor out the common variable, y, and take the coefficients and do the math with them. And then I just simplify, and I get x plus, and then 14 plus 22 is 36y. Okay? So that's how properties come into play. We don't even think about it. We use them all the time, but we don't ever put a name to it. So I'm just doing that now in your notes so you can see it. Now, the next one, let's see. I still want to get the order so the x's are next to each other. So I'm going to swap the order, which is our commutative property. And then I want to do, take these guys again, and use the associative property by saying, hey, these are the two that I'm going to do math with. I'm going to group them. Associative property. And then I'm going to use the distributive property by factoring out the common factor x and leaving behind the 3 plus 5. And poor 9y, don't you feel sorry for him? He's just like strung along. So then we're going to have, that's your distributive property. And then we just simplify. There we go, 8x plus 9y. And can't do anything more because x's and y's do not speak the same language. All right, that's it, guys. Sorry for the long notes. We'll see you tomorrow. Bye now.